Hello and welcome to this video. As you can see, after compound shapes, what we're going on to look at now is Pythagoras. Now, this is something you should be familiar with by now, okay? Pythagoras is used when we want to work out the missing sides of a right-angled triangle, okay? So remember, this only works for right-angled triangles, okay? There's a couple of ways Pythagoras theorem is written, but I'm going to go with the way you'll get it on your equation sheet, okay, so it keeps being familiar to you. And that is a squared plus b squared equals c squared, okay? And this means if you square one side, add it to the other side squared, you get the third side squared. But we need to be really careful with which side is which, okay? Because if we draw a right-angled triangle underneath it, oh dear, I know it doesn't look like a right-angled triangle, but if I put this little mark here, that makes it clear it is. Remember, this mark here means it's a right-angled triangle. So, in something like this, it doesn't matter which of these is A and B, okay? We could have this as A and this is B, okay? But C, that's the hypotenuse, okay? And that's always the side opposite the right angle, okay? And that's why these two add up to make this, because this is always the longest side of a right angle triangle, okay? And remember, we call that the hypotenuse. Okay, now, we need this, and we need to be able to work out Pythagoras, because it comes into play when we're doing like compound areas or perimeters and things like that, okay? So I'm going to, just down here, I'm going to pop in an example question that uses the compound area things we were looking at, but also requires us to know Pythagoras. Sorry, I should not have put a squared there. That's just C, that side, okay? So I'm going to put a question here that requires us to use Pythagoras to work out a compound area so we can see what we're building up towards. Then we'll do a little bit of practice on using Pythagoras and then tackle that question, okay? So just give me a second while I write the question out. Okay, so I've just popped down an example question here, and it would be something like this. Calculate the area of this shape, okay? Now, the length of this bit here is 10, and that's just from here to here. And then this side is 4. It is a 4, I'm afraid. It's a very badly drawn one, but it is a 4. And then this length here is 5. Okay, so we know what we'd do. We know what our general process would be. This would be shape 1. This would be shape 2. And we'd split it up into these shapes and work out the area of each. Okay, we could work out the area of shape 1 fairly easy. Okay, but for shape 2, to work out the area of a triangle, you need to times the base times by the height, okay? Well, we know the height of it here is 4, but we don't know the base of it, okay? We know this length here, 5, but that's not helpful to work out its area, and so that's when we'd need to use Pythagoras, to work out this side first using Pythagoras, and then work out the area, okay? So, let's have a look at some of this Pythagoras equation then, and get a bit of practice and get used to using it. Okay, so let's say then we're going to look at question 1, and I've got a triangle that looks like this. Okay, a right angle, very badly drawn again, I'm afraid, and it is 6 meters here and 8 meters there. Okay, so it's not drawn to scale, I'm afraid, and what we're trying to work out is how long side C is. Okay, so our equation, okay, I know it's a squared plus b squared equals c squared. It doesn't matter which one of these we pick for a and b, I'm going to call this a and this b. Okay, so that means then I've got 6 squared plus 8 squared equals c squared. Okay, we'll work this out. 6 squared is 36, 8 squared is 64, 64 equals c squared. So 36 and 64 is 100 equals c squared. But this is where we need to be careful, okay? Because this isn't c squared, sorry, it's asking for c. So we need to get rid of this. So this goes back to what we've done before with like rearranging equations and when we did Pythagoras last year, okay? So to get c by itself, what I do is I take the square root of 100 equals c, okay? Because the square root is opposite to squaring it, okay? Then the square root of 100, well, that means what number do I times by itself to make 100? We can use a calculator if we want, but that gives me c equals 10 meters, okay? So that's what size that side there is, okay? It's 10 meters. Okay, let's look at another one just so we can practice using this equation, subbing it in. Doesn't matter which way around our triangle's drawn, any orientation, as long as it's a right angle triangle, okay? This time, I'm going to say, let's say 5 here, meters, and 7 meters there, and we want to work out c again, okay? So, sorry, I'm just going to put a line in here to keep them separate. So once again, we're doing a squared plus b squared equals c squared. Again, doesn't matter which one we pick. I'll put a here this time and b here. So that means 5 squared plus 7 squared equals c squared. So 25 plus 49. You can use your calculator for these bits if you want, okay? But remember 5 squared just means 5 times 5. Equals c squared. So if I add these together, I get 74 equals c squared. And again, to get the c by itself, what I need to do is take the square root. Now, this one I can't do in my head, so you would use your calculator for it, okay? And you will get a decimal answer. So if the question is be nice to you, it will say how many decimal places to go to. If not, general advice, just go to 1 decimal place is probably enough, okay? So, on calculator, if you can't remember, square root button is normally around about here. Looks like the square root symbol with a little empty box in it. You just press that, then 74, press equals. It might display the answer in a square root. Then you press your SD button like you do with fractions, and it will change it to something with decimals in. And so it's 8.6, okay? So here, c equals 8.6 meters. Now, that's the basic form of Pythagoras, which we should be very familiar with, okay? That, however, is not quite what we need for this example up here. Because if we look at this, we already know c, that's the long side opposite the right angle. We already know the hypotenuse, and we want to work out one of the other missing sides, okay? And so we will need to use our Pythagoras equation, but we'll need to rearrange it, okay? So we'll look at an example here of it rearranged, okay? Let's say then I've got a triangle. It's a right angle. Let's go with this side is 3, this side is 5. What is this side that's missing here? So again, I'll just start by writing out my formula. A squared plus b squared equals c squared. Okay. Let's say this is a, this is b, this is c. And we'll sub in again. So a squared, that's 3 squared, plus b squared, because we don't know b squared this time, so we'll leave it. And we know c this time, so that's 5 squared. So that means I've got 9 plus b squared equals 25. I want to get the b squared by itself, so remember when I was rearranging before, if this is a plus over here and I move it to that side, it becomes a take away. So now I've got b squared equals 25 take away 9. So b squared equals 16. But remember, unfortunately, we're still not quite there, because I need to get b by itself. So this is squared at the moment. So what I'm going to do is take the square root of this one. So the square root of 16, again, you can use your calculator. It's what number times its by itself to make 16, and that is 4. Okay, so then the length of this side b here is 4. And that's exactly what we'll use on this example. Okay, now, most of the work I'm going to get you to do is going to be just using Pythagoras itself, and then I'll pop in a question or two at the end, which is more like this. So this type you see over here, this is how it will appear in the units, and this is most likely the sort of question you'd get in an exam, okay, where it would require you to use Pythagoras as part of something else, okay? But don't worry, if you take a bit of time just doing the basic ones to get it in your head, that's absolutely fine. But let's have a look at this then. We'll start with working out area 1. That's a nice easy one. It's just a rectangle, so its area is the base times the height. Base times the height. The base is 10, the height is 4, so that gives us 40. I'm going to put some units on there, sorry. Call them meters. So the area of shape 1 is 40 meters squared. Okay, now shape 2, little less easy. Okay, the equation for the area of a triangle, remember, is a half times the base times the height. Okay, you will need to remember this equation. You're given the Pythagoras equation in the exam, you're not given this, so you need to remember this. Okay, so we know the height of a triangle is 4, okay, because it's the same as this height here. We don't know the base of it, okay, so I'm going to label this base here B, and we need to work that out before we can put it in here, okay? So what I'm going to do is, I'm just going to put an arrow off to the side where we work out what B is, okay? And because this is a right angle triangle, we can use Pythagoras. So we've got a squared plus b squared equals c squared, okay? A must be 4, because that's the other side, that's not the hypotenuse. So that means I've got 4 squared plus b squared equals 5 squared. Remember, c is always the slanty side opposite a right angle. That means I've got 16 plus b squared equals 25. Get b by itself. What I want to do is move this over and it becomes a takeaway. So, sorry, b squared equals 25 take away 16. So b squared equals 9. Then to get b by itself, I move the squared over. Okay, it becomes a square root. And the square root of 9 is 3. Okay? So that means this side here, b, well, that's actually 3 meters. And now I know the base of that triangle and I know its height, so I can work out its area. Okay, so we'll carry on here then and sub those in. So it's a half times 3 now, because I've just worked out its base is 3 and its height is 4. So that equals a half times 12, which equals 6 meters squared. Okay, so that's the area of shape 1, the area of shape 2. And so then my total area, I'm just going to write TA, that will be 40 plus 6, which equals 46 meters squared. Okay, and that's a more advanced, tricky question that uses this Pythagoras skill you have done before, so hopefully are familiar with, and if you were starting to forget it, hopefully this is a good wee reminder of how you use it in its basic form, how you rearrange it, and then how you might use that in a more contextual example. Okay, right, if you didn't understand anything, just get in touch with me like normal, and thank you for watching.